we've looked at two ways so far to graph reflections. We've looked at the eyeball method, where we just kind of eyeball and use symmetry to figure out where our points will be located after a reflection. We've also used a couple rules to reflect over the x-axis and y-axis and a couple other special lines. It turns out there's a third way to do reflections as well, and that's to use matrix multiplication. So I'm going to show you how that works, although I'm going to kind of show you a way to cheat around that, because I don't really like using matrices to multiply anyway, but I'll show you how that process works. So we want to reflect this triangle over the x-axis and over the y-axis. Again, you already have a couple ways to do this. This is merely an additional way to do this. Multiplying using matrices to do an x-axis reflection, we're going to use the following matrix, which you have in your notes if you want to take a look at those. It's a square matrix that has 1 and 0 as the top row and 0 and -1 as the bottom row. We want to enter this in our calculator if we're going to do this multiplication as matrix A. You have to do it in this order, otherwise it's not going to work. Matrix B then is going to be our coordinate matrix. So I'm going to set that up. I'm going to do this in order, so D, E, and F, of course, as we've done before. I've labeled my coordinates already, so I know that D is at 2, 1. The way we wrote this in a matrix was the x coordinates went on top and y went on bottom. E was at 3, 3. And then point F was at 4, 0. And so if I'm using my calculator to do this multiplication, I'm going to enter that in as matrix B. If you need help with how to enter these in, go back and watch one of my previous videos about using a graphing calculator to multiply two matrices. Otherwise, at this point, I'm going to show you how to kind of cheat and get the answer anyway, because I don't like doing matrix multiplication. So even without using a graphing calculator, I know the coordinates of my image, and I'll show you how I can do that. So I'm going to label my matrix first, my answer matrix, D prime, E prime, and F prime. Here's how I'm going to do this. In the past, we've used an AB rule for multiplying across the x-axis, and looking back in notes or watching the video right before this, I can see that the rule was A, comma, the opposite of B, meaning we left the first coordinate, the x coordinate, alone, but we changed the sign of the second coordinate. Well, knowing that the x value is in the top of my matrix, and knowing that I'm leaving that alone, I know that when I do this multiplication, and you can confirm it using a calculator if you don't believe me, that top row, the x value is going to remain the same, but the y value, the bottom row, those signs should change. So I should get -1, -3, and then of course 0 can't change. So that's how I kind of cheat. I'm winking right now, you probably can't tell. That's how I kind of cheat to find this without even actually doing the matrix multiplication. I know that that's what this is going to end up as. Okay? Let's go ahead and do the y-axis one as well, and then I'll have you guys graph these to confirm that you do have the correct coordinates. Graphing's a great way to check these because we know what a reflection should look like. Alright, so for our second example, again, we'll set it up with matrices just to say we kind of did it that way, but we'll cheat to actually do the multiplication. Unless you like typing these in your calculator, then that's fine, go for it. To do a y-axis reflection, the matrix we discussed in class to use was this, -1, 0 in the top row, and then 0, -1. Once again, that must be entered in as matrix A. Matrix B will use the coordinates of our pre-image, so the same as up top. We've got 2, 1, 3, 3, and 4, 0. If you want to use your calculator to do this multiplication, now would be the time to do that. Just make sure this is matrix B and multiply in that order. Otherwise, here's how we're going to sort of cheat to find what our image matrix will be, the D prime, E prime, F prime matrix. Once again, using the old rules we've discussed, I know that a y-axis reflection, the rule we used was leave A alone, but then change the sign of the B coordinate. Nope, I take that back. I had that backwards, I'm sorry. Change the sign of the x coordinate and leave the B value alone, the second value alone. So everything along the top, because that's our x coordinate, our first coordinate, all those signs should change. So -2, -3, and -4. If you don't believe me, then do the multiplication in your calculator and you'll see that that's what we get. The bottom row then, the B value, the y coordinate, should stay the same, so that should stay 1, 3, and 0. And so that should be the matrix form of my image. Let's go ahead and graph these two coordinates and just see that that does in fact work out to be an x-axis and a y-axis reflection. Oops, hang on one second. Just realized I made a big mistake. Why Why didn't you guys stop me and tell me I did something wrong? How dare you? I realized for point D, oops, this was really bad. Point D is located at 1, 2, not 2, 1. It's over 1 up 2. So I had those switched around. Apologies. Which means then, let me go ahead and fix these before I graph it. So this coordinate D prime is going to be located at 1, -2 once I change that bottom sign. Oops, sorry about that, you guys. And then same thing down here. The coordinates for D I wrote down wrong. Apologies. So 1, 2 are the coordinates for D, meaning once I switch these around for my image, I should be at -1, 2. So now let's go ahead and take a look at the correct graph. Sorry about that. So here are what my two reflections look like. The orange was what we found with the x-axis reflection, and the purple is what I found with the y-axis reflection. Once I've gone back and corrected those 2 points, I accidentally mislabeled the coordinates for point D. So there's what our correct final answer should look like, using matrix multiplication, wink wink, to find those coordinates.